What would happen if the sun just disappeared one day? Since light takes 8 minutes and 20 seconds to reach the Earth, would we be flung before we even knew the sun was gone?
Not quite. In order to understand this question a little better, let's take a closer look at Einstein's general theory of relativity, specifically his definition of gravity.
Einstein defined gravity as the curvature of spacetime under a mass, so that the more massive an object, the greater the curvature. Here is a bowl with a plastic wrap that represents the fabric of spacetime. As evident, when you put a light object like a marble in spacetime, it barely bends at all. Meanwhile, a heavier object like a golf ball bends spacetime to a greater degree. Now let's see what happens when we remove the golf ball. Didn't catch it? Here's another one in slow motion. As you can see, the removal of the ball causes a wave to propagate outward. This wave has a speed, and the area in front of the wave is not affected until the wave has passed. Since the golf ball represents our sun, if it disappeared, it will also send out waves, gravitational waves. These waves travel at the speed of light, so we won't know that the sun has disappeared and will keep orbiting an empty center until the wave rolls over our planet and the light of the sun disappears.
Full disclosure, the sun won't just disappear, thanks to the law of conservation of mass. However, gravitational waves still exist.
They were first directly detected at the Laser Interferometer Gravitational Wave Observatory, or LIGO, on September 14, 2015, and were dubbed the chirp heard across the universe. This chirp happened when the light from two merging black holes could finally be seen.
But wait a minute, we can't see black holes. At least not without a lot of work. Which is why gravitational waves are so important. This phenomenon is another tool that scientists can add to their toolbox, another way that we can understand the universe around us. In other words, gravitational waves allow us to witness events that we cannot otherwise see with our eyes, such as the collision of two black holes. This added information actually allows us to understand the universe through a different lens.
For example, the synthesis of heavy metals such as silver and gold were originally thought to have come from dying stars in a violent explosion known as a supernova. However, scientists now hypothesize that this synthesis actually occurs in the collision of two neutron stars. This collision, known as a kilonova, synthesizes new metals in a violent crash before the metals are flung into space, an event witnessed due to gravitational waves.
So although the sun won't disappear, the concept of gravitational waves will still help us unlock the many mysteries of this universe.